All right, we're going to continue talking about how to calculate probabilities using the binomial distribution, starting by reviewing the variables that we learned about in the last lesson. First, we want to remember that the number of trials in the experiment is denoted with the letter n. The probability of success for each trial is a lowercase letter p. The probability of failure for each trial is a lowercase letter q. And the number of desired successes, that would be what we're finding the probability of. We denote that with the letter R. So we're always looking for the number of desired successes out of the total number of trials. We're going to start by looking at an experiment involving a basketball player. The player is known to make 65% of his free throws. Suppose the player is asked to shoot 16 free throws and the number of shots he makes is recorded. In this case, the total number of trials would be the 16 free throws. The probability that he makes a shot, that would be your success, is 65%, which we want to change to a decimal value of 0.65. That means automatically that the probability that he misses the shot or fails to make the shot has to be 0.35, because remember, the probability of success and failure, those two probabilities added together must always equal 1. So we have this complicated looking binomial distribution table in the back of your textbook. It's 4 pages long. The first thing we want to look for is the correct number of trials. That'll be listed in the first column of the table. We need n equal to 16. If you look at my snapshot of the table, I circled where n equals 16. You need to find that page of the table. It should be the 4th page in table 3 in your textbook. After you've found the correct page of the table to look at, you want to find your p-value across the top row. For our experiment, p is 0.65. So I highlighted the column that we'll be using for our problem. We won't have to look at any of the other numbers on this table to answer the questions that are given next. Only the column where p equals 0.65 in this chunk of the table where we're looking at 16 trials. So let's actually look at an example problem. If I want to find the probability that the basketball player will make exactly 5 of his free throws, I want to find the probability of 5 successes. So we need to look for the row on the table where R equals 5 in the P equals 0.65 column. That's the one I already circled on the last slide. So looking back at the table, the R values are in the second column next to where you see n equals 16. I'm highlighting the row for where R equals 5. All of those probabilities are related to 5 successes out of 16 trials. We only want to consider when the probability of success is 0.65, so I highlighted that column. Where that row and column meet, that's the probability that we want. That's the probability that this player makes exactly 5 out of his 16 free throws. The way that we would show that with our proper probability notation, the probability that R equals 5 is 0.005. For this second question, what is the probability that the basketball player will make at most 6 of his free throws? Using what we've learned before, and if you understand how to look at the table now, it might be a good idea to pause the video and see if you can find the correct answer before continuing. First, I want to consider, what does it mean to say at most 6? At most 6 means that the player could make 0 shots, 1 shot, 2 shots, 3 shots, 4 shots, 5 shots, or all 6 of those. Remember, if I'm combining the events with the word or, I'm looking at adding probabilities together. So I want to find each of those 7 different probabilities and add them all together. I want to look back at the table. Now, instead of just looking at one row for R, I'm looking at all of the values from r is 0 to r is 6, and still highlighting that column where the probability of success is 0.65. Those 7 values need to get added together to give me my total probability. Thankfully, the first 4 are zeros, so I don't really have to worry about those. When I go back to calculate my probability, the probability that r is less than or equal to 6 is the 0.001 plus 0.005 plus 0.017, which gives me a total probability of 0.023.